These are my notes to self. So hi, I'm Kelsey. If you've seen me around the internet before, it's probably associated with one of these pictures. I don't actually officially control the Tessel Twitter account, but I think I'm the only one who actually uses it. Can I have a show of hands? Have you heard of Tessel outside the context of reading this program? Okay, oh, that's a lot. How about, have you ever tried one? Ah, well, you're the perfect audience then. That means I don't have to explain everything about it, but I get to show you what it looks like when you start. And since a lot of you haven't tried it, you won't be totally bored because a lot of the material for this talk just comes mostly directly out of our just first run experience. So that's dual-edged. If you had tried it before, it might be a little boring, but since you haven't, it's great because if you go there to tessel.io/start, which is actually this redirects directly to here, then you're welcome to delve into any of the things that I'm trying today and see the code yourself and try it out. So I'll give you a very brief introduction to Tessel's history because I think it's worthwhile. Around the end of 2013, or sorry, around May of 2013, which was the end of my university career thus far, we were experiencing, there were a group of us who were trying to make things for the internet, to try and create shared experiences of, the original proposition was from Facebook, to see how you could bring your digital interactions into the physical world, and vice versa. And after about a year of working on that project, it became quite clear that it was just really hard to make an internet-connected thing. We've come a long way since then, as a global hardware community. It's much easier now to get a cheap, relatively easy-to-use Wi-Fi connected thing. But we said, we were a part of that movement, so we said this is something that should be easier, and specifically, who better to make internet-connected devices that interface with APIs such as Facebook, such as literally any API, than people who already are familiar with building and using APIs, and that would be web developers. So we created Tessel, basically in the hope of creating a friendly space in the hardware world for web developers. And we decided that that took not just code, but also physically building our own hardware platform, which this is the Tessel 2, which, well, going back to my history lesson, May of 2013, we thought about doing this, decided to do it. September, we crowdfunded, got VC funding in November, built the thing, shipped it in March of 2014, and then kept working on that all the way around to February of 2015, and said, hey, you know what we should do is build a second Tessel, a Tessel 2, that fixes everything that we did wrong with Tessel 1, like a huge code refactor except for its hardware. So we decided to make this board here. Not long after that, something that we had expected to happen didn't happen. And that specific something was getting follow-on investment as our company. So we realized very quickly we weren't going to be able to continue existing, which was tricky having just launched a product that we were super excited about. So we did the unusual choice of deciding to just not be a company and keep working for free indefinitely, which we do now. Starting in May of 2015, we just switched to being an open source project that has, nobody gets paid to work on this. But as a passion project, we shipped Tessel 2 earlier this year, a couple months ago. And brand new software, brand new hardware, much of the same user experience that we liked from building Tessel 1. So I told myself I'd keep it brief, so I guess I'll get into the hardware bit. The rest of this will mostly just be me playing around. I have some ideas, some plans of what I'm going to do, but it all kind of depends on how long I have. I might just throw more in there. So let's see. Yeah, very brief history. List and rename. Cool. So I have this camera here that Flocky just lent me. Thank you so much, Flocky. It lets us have this much nicer experience with it. And you can see here that I have created a folder called Ruhr, which has nothing in it. And you can see it over here in Atom. So here's the very basics of connecting to Tessel. I have it plugged in via USB. It's a standard USB-C. And I'm going to show it off, or sorry. So you would install the command line tool with npm i-g t2-cli, which is, written here. I've already done that, so I will skip the npm install on stage at this time, and run t2, so you can see, actually, resolution here is a bit tricky. Let's see. You can see all of our docs for what the CLI does. There's a number of interesting things, notably root, because Tessel 2 is technically a Linux device, even though we abstract that away. So t2 list, and it found my Tessel. And this is the Tessel's MAC address, and that's a really unfriendly name, so I'm going to say t2 rename something clever. Great. So now if we run list, great, so we see it there. And I did say this was an internet-connected thing, so I'm going to say Wi-Fi-n, what's the one here? Oh, why am I on that? RuhrJS conf. There's an underscores in there. Cool, so I've just passed that over to the Tessel, and if this works, the yellow light's blinking. And how well can you guys see that? In the back, is that too hard to see? It's working, great, thanks. Very responsive. Cool, so that's Wi-Fi, that's pretty cool. So I can do, in this blank folder, let's do t2 init and start making some code. Cool, so t2 init is effectively our version on npm init. We decided it should be more opinionated after doing a lot of teaching workshops. I've done a lot of teaching workshops with Tessel specifically, but it's come out that there's just a lot of people who want to learn Node or want to just be introduced to the concept of coding through something physical, which I think is quite cool. Because of that, I've done a couple of things. One is this particular t2 init command. You don't have to pass in a -y mysterious flag, because a lot of what happens when brand new people to coding install Node and try and run npm init, they're like, okay, I think I did it, but they're just looking at the prompt and not answering it, and they're worried that pressing buttons is going to do something. Along that same vein, actually, this is a bit of a tangent, but I wanted to make this accessible to everybody, so I have used this as something to teach coding to brand new people before. And I wrote this tutorial. You see this as step 1, but there's a step 0, which will show you how to use the command line if you've never done it before, which I thought was pretty fun. I wrote this because I was frustrated when I was learning, so it says, like, here's what a text editor is. This is what it'll look like to do a CLI thing. Anyway, you all know what you're doing, but I thought you'd like that. Cool, so back to what we've just written. You can see that we've created 3 files with this t2 init command. One is a package.json. If you're familiar with Node, this is a standard thing to have with just some metadata about what you're working on. It's important to have it for Tessel because it uses it to, as part of its process for sending the code over to the microcontroller. This Tessel include is something you can read about later if you want. It's not that interesting right now. And index.js, we have automatically written a blink script. So if I run this, the LEDs will blink. This is a little longer than I want it to be, so I'm just going to start from scratch. And I'm going to say Tessel. This is how you require the hardware API. So I'm saying, hey, I want to use the library on Tessel, which is built into the Tessel itself, to access the LEDs that you have. So then we're going to say set interval. Let's do LED 2. Okay, great. So this should be reasonably intuitive for JavaScript programmers. We're setting an interval that every 10 times a second, every 100 milliseconds, toggles the Tessel that is at the array index 2. So if it's off, it'll turn it on, and if it's on, it'll turn it off. How do we run this? Oh, and I'll let you see it too, I guess. Cool, so it's deployed and it's running, and the light that you see blinking right now is the Wi-Fi one. Ah, there we go. So you can see it a little bit. Let me get this closer. That green one is going. Yeah. Cool, so that's the first thing. So what you've just seen is what you often would get in electronics first day is you get there and you mess around with wires and you learn about electrons and you're excited about circuits, and then you say, okay, what are we gonna do? And they're gonna say, we're gonna blink an LED, and you're gonna be so happy when it blinks. Personally, I think that's a really good start, and really only a start. And if you end the first day and all you've figured out how to do is blink an LED, you might be a little frustrated to go further. So let's make it a little bit more interesting. This won't change a whole lot, but it's a little prettier. Am I missing anything? My brain is kind of blank at the time. Should just toggle them in order, right? Cool. So while this is pushing over, I'll tell you what the next thing I'm going to do is, which is, it's all well and good to have your thing connected. Oh, what have I done? Oh, right, an if statement. Because I only have a certain number of LEDs, I can't toggle like 1,000 of them in order. How many do I have? Great. Right, so it's all well and good to have this connected to my computer. But one thing that's even cooler is if I can, oh, there we go, now it's doing the thing. I think I skipped one, but who cares? So I would like to be able to deploy this, now that I have this connected to the Wi-Fi. I can list again, and I can see that, oh, I forgot that I'm not on the same Wi-Fi as it. Hey, how did it find that? Cool. So it says that it sees the same something clever thing listed on USB and LAN, but it says, oh no, but we're not provisioned to use the LAN connection to push code. And this is our security of, it's really important for, wait, what the heck? How did it find it on the wrong Wi-Fi and not on this one? That is really cool. There it is. Oh, okay, cool. So anyway, so I'm going to run this T2 provision command and say, hey, I'm a safe computer. I own this Tessel, and if you have physical access to a Tessel, you also can run this. So we figured that if you had physical access to a device, you probably could figure out how to root it anyway. So provision. So I'm going to say this laptop is safe. I can use it whenever I want. And before I unplug this, I'm also going to say T2 run was to test my Blinky code. And T2 push is to run it whenever it gets power. So if you just have like your Tessel plugged into a wall somewhere, you can go ahead and do that. Okay, great. So that's running. I'm going to unplug it. I'm going to plug it into here and turn it on. And I should show you that, voila, the Tessel is free. It is not connected to my computer. I need a assistant who can gesture for me. This lovely fading LED animation is our PWM implementation, and it shows that it's booting up. So while that's going, here we go. So it's now gained power, and the Wi-Fi has connected itself. And now, shortly, fingers crossed, everyone. There we go. Cool. So you can see that the LED on the end is missing from my display, and the actually impressive thing is that pushing code over LAN. So let's do that instead. So I'm going to do the same thing, and it's not going to take quite as long because it's already booted up. And remember, it's still on, ooh, fascinating. I think I might have to put a timeout on because there's so many devices connected. Come now. Oof, okay, well, let's just skip that for now. It's all well and good, but you're probably tired of LEDs blinking. I know I am. So, but I'm happy to show it to you working in the break. I'll investigate that one later. Cool, so I said LEDs blinking, not so interesting, so let's add a sensor to it. So this is an accelerometer. This is one that we make, but you can actually buy this sort of thing online as well. I'm going to plug it in. You can see that it's pretty clear where it might go. These are labeled on the board as port A, port B. So I'm going to say, one final thing. It has this name on it here. Come down. Physical things are hard. So I would like to use this accelerometer. So I would like to use the library that's built for this device. Okay, so you can see I've got a node modules folder, I've installed the npm thing, and now I'm going to say var accel equals cool. And we don't need any of this blinking nonsense. We're going to do, meanwhile, I'm going to erase that code that continues to be blinking it, as you see. It's done. I think I'll bring this back up. How good is that? All right, cool. Thank you for joining me on my learning process with these tools. Cool. So, and I've forgotten something, which is, so you remember I said that I plugged it into port A, and now I have to tell it in code that yes, indeed, I did do that. So this is event-driven. Cool. So I'm saying anytime I get data off of this accelerometer, I would like for my code to tell me. So I'm using this library, it's giving me data, and I'm writing out the data that it has to here. And there's my data, cool. And if I make this nice and big like this, you can kind of see, it's a little bit hard to see, but like if I knock this around, it's a little bit clearer that it's moving around. So this is too much to take in at once. Let's just look at one axis and see if we can manipulate it. So let's see, it's x, y, z in order in an array, so it's actually going to be 2 if I just want z. Let's run that. In the meanwhile, I'll make this a bit nicer. Cool, and it looks like it's running. So, okay, so this is the z-axis. So here's the thing, this is an accelerometer, and a lot of people think about accelerometers as like, oh, you're measuring movement, so you must be, in order to use this, you must be dancing around like this, or making gesture-controlled things. Actually, the much more common use is just to know which way is down, because gravity is a constant acceleration. And so it's the thing that's in your phone, if you want to turn it to adjust which way your photo goes, that sort of thing. So we can do something quite similar, so you can see that right now, we get a consistently above 0 thing. And this way we get a consistently below 0 thing because we're manipulating the z-axis by flipping it over. So that's a good way. Oh, sorry, I'm not showing you the camera. You got the idea. So this is the next bit of, well, we have a sensor, that's great, but I have a bit of a pet peeve with people who are excited about technology without wanting to solve a problem. So I'll show you how this can be used to solve a problem. And what's more, like, I think the really exciting part about getting into hardware is that you have a whole host of new, interesting, complex problems to solve. And one of my favorite ones is, how do you, ooh, interesting, that's reported. One of my favorite things that you can do with that, one of my favorite problems that it presents is trying to figure out what the appropriate form of sensing is for a given problem. So I've had a lot of people ask me, for example, how do I know, I want to get a notification whenever my mailbox is opened and my mail has been delivered. So you can measure that in a couple of ways, right? You can say, okay, well, I want whenever the mailbox gets bumped, or maybe I want to measure the light, or maybe measure the sound of the mailbox opening and closing. And so this is actually one of the answers to that question, or a similar question in my case will be easier. What if I want to measure when a book has been opened? Just because that's simpler for me to go like this than to try and do a mailbox simulation. What? Yes. Stop it. Come on now. Cool. Great. So about making useful data, z equals x, y, z 2. That's something simple. If z is greater than 0, just as we showed. Or, actually, cool. So we're going to say that an open book, oh, yeah, we're going to say that this is a closed book, and an open book would go like that, I suppose. Oh, I forgot that you can only see what I see here too. So anyway, closed, open. Cool. Try that again. T2 run index.js. Building project running. Okay, the book is open. And the book is closed. Open, closed. Great. Now we've turned a stream of data into something that we actually might care about. Of course, it's super annoying if it keeps yelling at us, so let's say, actually don't want to set that. So I'm just saving the state of the previous. Oops, I've forgotten something. I don't need to do that. Whatever. Cool, so now we should only get notifications when something changes. Book is open, and not yelling at us, and then book is closed. Great, so that works. So we care about that because we might want, for example, if this is a very important old book, maybe there's a library somewhere that has one copy of this book and everybody wants to know how it's getting used. I don't know. This is a very strange hypothetical world. But say the whole world wants to know, where would you go? You would go to Twitter. you'd created a stream that everyone can subscribe to. So I'm going to mostly copy and paste this because it's a lot of stuff that we don't care about. Cool. So I'll show you here that we've got Twitter. This is node required. And I need to install it. It's bound to go well. I will copy that from another folder if it takes too long. Cool. We're going to say we are at RuhrJS. So we're requiring the standard node library for Twitter. We're setting a message that says, hi, we're speaking. These are some OAuth credentials. You can have these. These are already free on the internet. This has been up here for 3 years, and Twitter hasn't batted an eye at it, so don't abuse it, please, though. I like having them. But yeah, so this makes you not have to go through in your first run experience the whole pain of setting up with how do you make a Twitter app and sign up as a developer. And then this is the standard Twitter library to post a status. Great, our thing installed. So this is just going to send one tweet, and I'll preload. Oops. / yeah, Tessel tweet. All right, it's working, it's working. Running the script. And cool, it says it tweeted. And this is me testing yesterday. And hey, look, there's the tweet. Cool. Great, so now we can tweet from a microcontroller. That's great. We absolutely need more of that in our lives. And in order to tweet about the book, it's very simple because, once again, this is just Node. I shouldn't say simple, I should actually say similar. It is actually quite similar to what we do. I'm still going to need to set up Twitter. Copy in those same OAuth credentials. You're welcome, world. This is what security should look like. And then, yeah, instead of logging the message, or in addition, let's just do it in addition. And the status is going to be message. And we're also going to say, because it's Twitter, so you can't not hashtag that properly. Oops, wrong one. We are now in, okay. A lot of anticipation going on. You know exactly how long this will take, so. Building the project, writing it to RAM. You're welcome to start a drum roll if you think that would help build the anticipation. The book is open. It tweeted. Well, that's loading. The book is closed, and it's going to tweet. OK, great. Well, that was fun. Lewis, do you need me to get off the stage, or can I keep playing? All right, well, I'll go just slightly further, because I think, yeah, there it is. It's on Twitter. Great. You can all retweet it if you feel strongly. I do feel like I should do one more thing, just because I promised in this title here to web-controlled device, and this is technically like a device that's controlling the web. It's just different. Although I do like that term, that phrasing. Yeah, access point and web server. So I'm actually going to make a new OK, so I'm going to work in this new folder web server, which, as you see, is empty. So I'm going to T2 init it again. And so what I'm going to do next is actually largely straight off of here, but I think you guys will like it because it's, or you all will like it because it's just kind of tech goodies, like things that you might sometime like creating your own local internet. So here's the really easy trick. T2AP-N. I'm setting Tessel to make an access point with the network name of Tessel. It's connected. Cool, so if you look in your Wi-Fi, you should see that there's now one called Tessel. And you're welcome to play along from your phones. The next thing we're going to do is build a web server on this. And sorry, I'd usually talk you through all of this, but I think I'm a little shorter on time than I ought to be. So I'm still going to use Tessel. I'm going to make an HTTP server using the HTTP library and its standard API. If you want to learn more about that, read their docs. Server.listen, and log that the server is happening. Okay. And I will also connect to Tessel. Cool. So if you are connected, you can go to this page, and excellent. Hello from Tessel. So Tessel is now serving me this website, this web page, and to all of you if you're online. That's great, but again, I promised control of something. So we're going to make a prettier web page. And again, please hit me up in the break if this is confusing, because I'm going over it super fast. You are welcome to read it here. We did write it out a bit better. So I have just an HTML page that's going to talk about LEDs, because we're back to blinking LEDs, I'm sorry. And then I've added the script so the buttons with the LEDs do anything. And this is going on my server. You can see that it's still using the same stuff, but now we're doing a bit of URL parsing, so we're worrying about that. We're using the same HTTP library to create a server, but now we're parsing what the buttons do, which is a regex around the LEDs. You don't look too confused, so I'll keep going with that. And then, once again, we're going to listen, and this is actually a tutorial that was built by Hipster Brown in New York, so he got a bit fancy with making sure it reported back about what the LEDs were. And there's one more important thing. This is what this Tessel include file that I didn't introduce you to earlier does. Basically, Tessel wants to be efficient about the code it pushes over, because we don't really want you to download the entire NPM registry, require one thing, and then try to push it. It'll just break and everyone will be sad. Instead, it's going to say, well, I see you're only using the Twitter library, so I'm going to just take that and nothing else. The flip side is, if you want to use an HTML page or any other static includes, you list it here, which should be, it's basically the opposite of a get ignore. Cool. So yes, I'm sorry I went through that very quickly, but this is the fun part. Server is running. Go back to our site. Again, I'm still connected to that thing. Oh, and by the way, I think you can do, yeah, I can do it there too if that's an easier one to go to. That's an easier URL. And you're going to need to see this camera. And I'm guessing some of you have already found it. Yeah, some of you are already online and playing with these LEDs, which you are now able to manipulate from where you sit. So those blue and green LEDs, you can click them, I can click them. It's probably better if you just click them, because otherwise the camera goes away. Great. Isn't that fun? You've created a web-controlled device. Right, so feel free to hit me up if any of this is confusing. I promise that I'm much more coherent in person. I will probably give some variant on this talk in the future, so any in-person feedback is absolutely welcome, especially if something was just glossed over or you wanted to see more. With that, I guess I will let you go eat cake. Thanks.